Welcome to The Explainer. Today, we're totally cutting through the noise to unpack the exact biological mechanics of sexually transmitted infections. You know, we're looking at the raw science here, the pathogens, the pathways, and of course, the prevention.
Okay, let's dive into this. So, at its absolute core, a sexually transmitted infection is really just a biological event of opportunity. It's a pathogen that requires a very specific vehicle, which is sexual contact, to survive and jump from one host to another.
But think about it. If sexual contact is just the vehicle, what exactly is the invisible passenger hitching a ride, right? To really understand the infection, we have to zoom way in and look at the microscopic trigger. Which brings us to Section 1, HIV, the pathogen.
So, the crucial point is that the human immunodeficiency virus, or HIV, is the primary pathogen we're looking at today. And it's important to remember this isn't just some abstract concept floating around. It is a highly specific, totally tangible microscopic agent that actively drives the infection.
Now, scientifically speaking, we have to draw a really strict biological line between the virus itself and the condition that it causes. You've probably heard both terms used interchangeably, but is HIV the exact same thing as AIDS?
And this brilliantly illustrates the difference. Think of HIV as the spark, and AIDS as the resulting fire. HIV is the actual infectious agent entering the body. AIDS is the resulting condition that the infection can lead to over time. So you don't actually transmit the condition itself, you transmit the spark.
All right, moving on to Section 2, Mechanics of Transmission.
Okay, so there is a very rigid linear chain to this infection. First, the pathogen is present in a host. But get this, it's actually highly vulnerable. It can't just magically jump across the room to infect someone else. No way. It absolutely requires a physical bridge, a highly specific method of transmission. It's only when that physical pathway opens up that a new STI can actually take hold. If the bridge doesn't form, boom, the chain is broken. And honestly, because this chain is so rigid, the virus's greatest strength is kind of also its biggest weakness. If we can map out precisely how it moves, its transmission playbook, if you will, we expose exactly how to stop it from sustaining itself across a population. It's all about moving that pathogen from host to host.
Let's move to and see how this builds into Section 3, Resolution, Controlling the Spread.
Because at the end of the day, controlling the spread isn't magic, right? It's the deliberate biological disruption of transmission. By intervening, we are effectively blowing up that bridge we just talked about. And hitting pause on the pathogen right then and there, that completely prevents the progression to AIDS.
The source material states it absolutely perfectly. HIV infection may lead to AIDS. Honestly, that single sentence is the ultimate stake of this entire biological event. It's the whole reason why mapping the pathogen and disrupting its pathways matters so much.
So we've pretty much demystified the chain here, from the pathogen all the way to the potential condition. Science gives us the exact map of how the virus moves, but human agency, well, we are the roadblock. So knowing exactly how this biological machine operates, what is your role in breaking the chain? Thanks so much for exploring this explainer with me today.